As the technological revolution impacts all industries, the desire for smarter and interconnected devices continues to grow. This desire was the origin for the Internet of Things that is present all around now. However, as vehicles gradually become autonomous connected machines, a new advanced network, the Internet of Vehicles, or IoV for short, a special domain of the Internet of Things, come into play. Communication frameworks form the foundation of IoV. It is what enables vehicles to interact with other entities around them. Vehicle-to-vehicle or V2V allows vehicles to communicate with other vehicles using dedicated short-range communication frequencies. Vehicle-to-infrastructure or V2I allows vehicles to interact with roadside units such as traffic lights. Inter-vehicle is similar to V2V, but instead of a one-to-one connection, it allows a vehicle to interact with multiple other vehicles in the network. Vehicle-to-pedestrian allows the vehicles to interact with the pedestrian's mobile phone or Bluetooth headsets. Lastly, vehicle-to-cloud lets the vehicle connect to cloud-based platforms for data exchange and processing. Vehicle-to-everything, or V2X, employs all the previously mentioned frameworks with the goal of having a full integration of the vehicle and its environment. Vehicle ad hoc networks, or VANETs, purpose is to provide communication between vehicles and roadside infrastructure through V2V and V2I. Vehicle functions as nodes, but due to the behavior of vehicles, these nodes are always exiting and joining a network. Hence, the system is said to be dynamic. VANET's main purpose is to ensure the safety and comfort of drivers on the road. Expanding on VANET's communication frameworks, IoV includes V2C, V2P, and Inter-V into the mix, essentially forming a V2X communication network. Instead of just communicating with vehicles and infrastructure, IoV extends this to include common roadside appliances such as mobile phones and public networks. IoV's architecture can be split into three layers: perception, network, and application. The perception layer includes hardware required for data collection. Hardware such as GPS, smartphones, Bluetooth, roadside units, and in-car cameras all fall under this layer. The network layer is responsible for the visibility of the vehicles on the network. It transmits and receives information about the road conditions through Wi-Fi, 4G, or even 5G. Application layer processes, stores, and applies the gathered data. Some applications include vehicular cloud computing and self-driving functionalities. Attacks on IoV are similar to that of IT and IoT applications. However, as IoV involves human life, the severity and impacts of the attacks are greater for IoV. In addition, due to its nature, it is more vulnerable and sensitive than other systems. GPS spoofing replaces coordinates with incorrect coordinates, causing troubles ranging from simple erroneous data to potentially serious accidents. Man-in-middle attacks are made by a third party inserting itself in between the sender and receiver party, intercepting the data that is being sent. The intercepted data could be altered or stored by this third-party vehicle. Denial of service jams the network by sending large redundant messages, preventing or limiting other vehicles from using the network. This could affect the efficiency and availability of the network and even cause the collapse of the entire network. A civil attack is when a jamming signal from the attacker surrounds the target with dummy vehicles, which causes the target direct system to be blinded by false information. Security protocols play a major role in preventing cyber attacks. These protocols can be divided into 5 categories: intrusion detection, secure routing, authentication, data privacy, and access control. Authentication requires vehicles to register with a trusted third party, and every request made will have to go through verification. The trusted third party will allow or deny the communication request based on the vehicle information. Access control only allows access based on the vehicle's role or attribute, depending on the control model. Data privacy would assign vehicle pseudonyms in order to mask the user identity. The life cycle of the pseudonym depends on if the vehicle is transmitting through a trusted or untrusted authority. In conclusion, IoV is an emerging tech that is able to potentially improve road safety and traffic congestion. However, IoV is particularly vulnerable to cyber attacks due to its complex structure, and researchers have pointed out that full protection from cyber attacks is only achievable in the far future. Despite its vulnerabilities, it is still a crucial technology for advancing autonomous driving technology and ensuring traffic safety.